day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on matter and material, which consists of 47 marks. And for today's topic, we'll be focusing on organic chemistry. And that is going to be under question 2, which consists of plus minus 21 marks. So the mark allocation for paper 2 is that we have section A, which consists of 5 multiple choice questions and which have a total of 10 marks. We also have section B, which consists of structured or long questions and has a total of 65 marks. Now the total for paper 2 is 75 marks and the duration is 1 hour 30 minutes. The topics to be covered in paper 2 will be under the content matter and material, which consists of 47 marks and has a percentage weighting of 62. Then we have chemical change, which consists of 28 marks and a percentage weighting of 38. So we are going to start here with the isomers. It says here a structural formula of a compound. So a structural formula of a compound shows which atoms are attached to which within the molecule. So on this one here, we have an example of a structural formula. And then it says what? It says it shows which atoms, so hydrogen, carbon atoms, it shows which atoms are attached to which within the molecule. So we can see that the carbon is attached to a hydrogen. This carbon is attached to this hydrogen, and this carbon is attached to this hydrogen, and so on. Then it says atoms are represented by their chemical symbols. So we can see that the H here, it represents what? A hydrogen. The C here represents what? A carbon. And the O represents what? Oxygen. So atoms are represented by their chemical symbols. And then it says lines are used to represent all the bonds that hold the what? The atoms together. Okay, so in between here we have lines that are going to show the bonds that are holding the what? The atoms together. Then we have the definition there of a structural isomer. It says they are organic molecules with the same molecular formula but with different what? With different structural formula. So this one here, this one would be representing a structural formula. But then when we speak of a molecular formula, then as an example, we are speaking of, as an example, C4H10. So that would represent what? That would represent a molecular formula. So the definition says what? Are organic molecules that have the same molecular formula. So it means that if you are to check the molecular formula of the two structures, they are going to be the same. This is the same. This one represents what? It represents the molecular formula, but they'll have different structures. Then when we are speaking of a structure, we are speaking of this one here. Then we have chain isomers. Chain isomers, it says they have the same molecular formula, but it's different types of what? Different types of chains. As an example, what do we have? We have a butane, and then we also have what? 2-methyl what? Propane. So every time when you have isomers, you need to check according to the definition. What does the definition say? It says that for chain isomers, they have the same molecular formula. So if it's the same molecular formula, you can check that yourself. How many carbons do we have on this one? you will see that we have a total of what? We have a total of 4 carbons. And then how many hydrogens do we have on this one? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you need to actually count it for yourself. So this one, this C4H10, it represents what? The molecular formula of what? Of butane. And then the molecular formula of 2-methylpropane, again, you need to count the number of carbons. So 1, 2, 3, 4 carbons. And then H, how many hydrogens do we have on this one? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has what? It has C4H10. And then what does the definition say? Chain isomers have the same what? Molecular formula. So we can see that the molecular formula for butane is C4H10. And the molecular formula for 2-methylpropane is what? Is also C4H10. So the molecular formulas are the same. That's the first thing. But we have different types of chains. So how do you check the chain then? You need to count the number of carbons. So how many do we have there? It's 1, 2, 3, 4 on the longest chain. We have a total of what? We have a total of 4 what? Of 4 carbons, right? But then when you look at this one, it will be 1, 2, 2, and 3. So on the longest chain there, how many carbons do you have on this one? On this one, you have 3 carbons on the longest chain, and then you also have what? You also have a branch, which is your CH3. So what did you do? You change the chain from having how many? From having 4 carbons to having how many? To having 3 carbons in what? In the longest chain. So that is your chain isomer. Then the next one is a positional what? A positional isomer. It says it have the same molecular formula but different positions of the. It can be a side chain, number 1. Number 2, it can be a substituent. And then number 3, it can be what? A functional group on the parent chain. Okay, so what's the first point there? We are saying that with the positional isomer, we have the same what? The same molecular formula. So again, you need to check the number of carbons on this one. How many do we have? We have 1, 2, and 3. So therefore we have how many carbons there? We have 3 carbons in total. Then next, what are you going to count? You are going to count the number of hydrogens. So we have 1, 2, 3, 4, 5, 6, 7 hydrogens. And then we'll also see that you have what? You have a chlorine. So again, you need to check this one. So this one was a 1-chloropropane. This one is a 2-chloropropane. You also need to check the molecular formula of this one. So how many carbons do you have there? It's 1, 2, 3 carbons. And then how many hydrogens? It's 1, 2, 3, 4, 5, 6, 7 hydrogens. So you will write what? H7. And then again, you will see that you have what? You have a chlorine. So you will therefore write your Cl. So according to the definition, what is the first thing there? Positional isomers have the same what? Molecular formula. So there is your molecular formula for the first one, 1-chloropropane. There's a molecular formula for the second one, and you see that they are exactly the same, and that is according to what? According to the definition. But again, the definition says what? But different positions. Okay, so right now you will see that the chlorine, even according to the name, right, the chlorine was on position number what? Was on position number 1. Remember, this carbon can represent position number 1 if you are counting from the right hand side. But again, if the chlorine was on the left hand side, this side, then this carbon would be representing what? Would be representing carbon number 1. So right now the focus is where? The focus is where the chlorine is. So the chlorine is towards the right hand side, so therefore this one will be your carbon number 1. And then when you look at the second one, where is your chlorine? So if you count from the left or you count from the right, you will see that the chlorine is on position number what? Is on position number 2, and hence the name what? 2-chloro what? Propane. Alright, so the definition says what? You have different what? Different positions. So again, on the first one, the chlorine was on position number what? On position number 1. With the second one, the chlorine is on position number what? On position number 2. So according to the definition, you have the same molecular formula, but what happened to the position of the chlorine? You change the position of the chlorine from position number 1 to position number what? To position number 2. Let's have a look at the second one. You will do the same for the second one. You need to count what? The number of carbons. And then you will see that you have how many? 1, 2, 3, 4, 5, 6, 7, 8. You have how many carbons? You have 4 carbons. And then you have how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8. What? 8 hydrogens. Then again, you count this one. 1, 2, 3, 4 hydrogens. 4 carbons. So you write C4 and then 1, 2, 3, 4. 5, 6, 7, what? 8, what? 8 hydrogens. So again, according to the definition, what do you have? You have the same what? You have the same molecular formula, but you have different positions. So again, according to the name as well, you see the name for this one is what? Is but1ene, meaning that now you have moved what? The double bond from position number 1. So if you are to count, this will be carbon number 1, then carbon number 2, number 3, and then number 4. So if you are to count this one, carbon number 1, number 2, number 3, and what? And number 4. So on the left hand side, you have moved the double bond from position number 1, and then you have moved it to what? To position number 2. So again, positional isomer, you will have the same what? Molecular formula as we can see here, but you will have different what? You will have different positions. So when you change the position, when we change the position of the chlorine, the IUPAC naming also changed. When we change the position of the alkene, what happened to the IUPAC naming? We can see that the IUPAC naming also did what? It also changed. Next one, we have what? We have functional isomers. Functional isomers, it says they have the same what? The same molecular formula, but this time what's happening? But this time we have different what? Different functional what? Functional groups, okay? So as an example here, we have what? We have methyl methanoate. The methyl methanoate. So the methyl part, remember, is for the what? Is for this side here, which is representing the alcohol side, and then the methanoate, remember, is for the carboxylic acid part. And then ethanoic what? Ethanoic acid. Okay, so this one, the first thing is what? Is that when you have a functional isomer, you will have the same what? You will have the same molecular formula. So again, you need to check what? You need to check the number of carbons that you have there in total. So how many carbons do we have? We can see that we have 2 carbons. Then what's the next step? We need to check the number of what? The number of hydrogens. So how many hydrogens? It's 1, 2, 3, 4 hydrogens. Then how many oxygens do we have in total there? We have 2 oxygens in total. So our molecular formula is C2H4 and then what? O2. Then next we check this one. How many carbons do we have there? It's 1, 2 carbons, and then how many hydrogens do we have there in total? It's 1, 2, 3, and then what? And then 4. And then how many oxygens do we have there in total? We have 2 oxygens. So again, going back to the definition, functional isomers have the same what? molecular formula, you have verified that, but you will have a different what? You have different functional groups, okay? So for this one, you can also use CAKE. So meaning that now, for example, we can see that this one is what? Is C double bond. So this one here is C double bond O and then O. So what are we given? You are given what? An ester. You are given an ester. So if you are asked for a functional isomer and you are given an ester, then you will know that you need to write what? You will need to write a carboxylic what? A carboxylic acid. And vice versa, if you are given what? If you are given a carboxylic acid, then in terms of the structure, that means that you will have to draw what? You will have to draw an ester. Then another example of a functional isomer, if you are given what? You are given an aldehyde, then you will have to give what? You will have to give a ketone. So a carboxylic acid goes hand in hand with what? With an ester. An aldehyde goes hand in hand with what? With a ketone. So I said if you are given what? A carboxylic acid, you'll have to give what? An ester. If you are given an ester, you'll have to give a carboxylic acid. And then if you are given an aldehyde, you'll have to give a ketone, or if you are given a ketone, you will have to write what? Or draw what? An aldehyde. As the definition says here, that whatever that you are going to draw, whether it's a carboxylic acid or an ester, it must have what? Same molecular formula, but you'll have different what? Different functional groups. Okay. So as we have said on this one is what? We said because of the C double bond O and the O, we said this is representing what? An ester. And then we said this one, C double bond O and the OH there, it is representing what? It is going to be representing what? A carboxylic what? Acid. Then we have esters. So with esters are a combination of what? A combination of alcohol plus by what? Plus by the carboxylic acid. And they are going to give us what? They are going to give us an ester plus by what? Plus by water. So as an example here, we can see that we have one carbon there, the 3 hydrogens, and what? And the O and what? And the OH there, which shows that this OH, it shows that we have what? We have an alcohol. And then the name of this alcohol is what? Is going to be what? Methanol. So if this was an alkane, right? So if this was an alkane, then we know that we are just going to remove the E, replace it with the ON, and that would then represent what? The alcohol. On this one, we can see that we have what? A carboxylic acid. Remember, with a carboxylic acid, how do we see that we have a carboxylic acid? It is represented by that C double bond O and what? And the OH. So it's a total of how many carbons there? It's a total of 4 carbons. So therefore, if it was an alkane, we would call it what? A butane. But because it's a carboxylic acid, we are therefore going to call it what? So we replace the E, and then we are going to replace it with what? With the oic what? Acid. Okay. Then when it comes to the combination now for you to form an ester, so we are saying esters will be formed by the combination of what? They will be formed by the combination of alcohols and carboxylic acid, and that will give us what? It will give us an ester plus by what? Plus by water, which is the same as what? As H2O. Okay, so let's see now. We can see that from the structure of the alcohol, what are we going to remove from the alcohol? We are going to remove the hydrogen. And then from the structure of the carboxylic acid, what is it that we are going to remove? So the carboxylic acid, we are going to remove this part here, which is your OH. And the combination of these two, the H and the OH, they are therefore going to form what? They are going to form your structure of what? Of H2O. So from there, what happens? You will see that you had this alcohol part, which is 1 carbon and how many hydrogens? And 3 hydrogens, and the oxygen. So I'm not going to change anything. The only thing that I did there was that I removed what? I removed a hydrogen, and then what do you do next? You redraw the structure as it is. Then you move on to the carboxylic acid part. On the carboxylic acid part, what did you do? You removed the OH. And then, so you remove the OH, and then what are you left with? You are left with this part. So now you are just going to connect this part with what? With this part here. So once you do the connection, so I can label this one part A and then label this one part what? Part B. So there is your part A there, and then this one, it represents what? So this is your part A, and then this one represents what? Represents your part B. And then plus by what? Plus by the water. So again, esters, combination of what? Of alcohols. So this is your alcohol part, part A, and then this is your carboxylic acid part, which is part B. And then an ester is therefore formed when we have what? A combination of the two, plus by what? Plus by the water. So now we need to talk about what? We need to talk about the naming. So how do you name your esters? When you name your esters, then you are going to start with what? You are going to start with the alcohol part. So the alcohol part, we know that it is what? It is part A. So if the alcohol part, because it contains 1 carbon, if it was an alkane, then the alcohol part would be what? Would be methane. But because it is an alcohol, it means that now we are going to remove this A, and then we replace it with what? We replace it with the YN. And then the carboxylic acid part is your part B. So again, if this was an alkane, it would be called what? It would be called butane. But because it is an ester, then you are going to replace only the E with what? With the O8. Okay. So just to repeat for you again, when you name the esters, you always start with the alcohol part. So let's say that the alcohol part was maybe on the right hand side, it was this side, and the carboxylic acid part was on the left hand side. It does not matter. You are always going to start by naming which part? The alcohol part. And the alcohol part, it is the one that is connected to what? To the oxygen. So the alcohol part, again, we said it consists of what? It consists of 1 carbon. So because it consists of 1 carbon, we are therefore going to call it what? A methyl. And then the carboxylic acid part, it consists of what? It consists of 4 carbons, but it has what? For you to see that you have the carboxylic acid part, what is it that you are going to see there? You will see the C double bond O. So again, we said it consists of what? Of 4 carbons. So therefore, the name will be called what? Will be called butanoate. Okay, then we have alcohols here. We have a primary alcohol. It says the carbon atom which carries the OH group is on the end of the of the longest carbon chain. So this is the carbon atom which is carrying the OH group, is on the end of the longest carbon chain. This carbon that is carrying the OH group is on the end. You see, it's towards or on the end of the what? Of the longest carbon chain. So remember, on the end, it does not have to be towards the right. On the end can also mean that the carbon atom which carries the OH group can also be where here on the first carbon, as long as it is towards the end. So towards the end can be the first carbon or it can be the last carbon. Secondary alcohol, it says the carbon atom with the OH group attached is part of the carbon chain which is joined directly to two carbon groups. So this carbon which carries the OH group is attached to two other carbons. So I am repeating, I'm saying this carbon that is carrying the OH group is attached to what? To two other carbons. That is a secondary alcohol. Primary alcohol, this carbon that is carrying the OH group is towards the end, but I said the end can be the first or it can be the last carbon. Secondary alcohol, this carbon that is carrying the OH group is joined directly to what? To two other carbons. Then we have a tertiary what? A tertiary alcohol. The carbon atom holding the OH group. So this carbon that is holding the OH group is part of the carbon chain which is attached directly to what? To three carbon groups. So this carbon that is holding the OH group is attached to three other carbons. So this is carbon number 1, number 2, or carbon number 3, or carbon number 1, number 2, and carbon number 3. So tertiary, the carbon holding the OH group is joined directly to what? To three other carbons. So that is our tertiary what? Our tertiary alcohols. So again, you need to know your homologous series, your alkanes, alkenes, alkynes, haloalkanes, alcohols, aldehydes, ketones, carboxylic acids, and what? And esters. Then you need to know all the structures of by heart. Otherwise, you will not be able to do what? You will not be able to do your IUPAC naming. So when you see an alkane, you need to see what? You need to see single bonds. And this is according to your examination guidelines as well. When you see your alkenes, then you need to recognize what? Your double bonds there. When you see alkynes, then you need to see what? Triple bonds there. And then CX, remember we said X represents what? The halogens. The alcohols, it's OH and a hydroxyl group. Aldehydes, C double bond OH, that is your formal group. The ketones, it's the C double bond O, and it must be in between what? Two carbons, two or more carbons, and that is your what? Your carbonyl group. Then the carboxylic acid, it's the C double bond O and what? And OH. A carboxyl group. The esters, it will be the C double bond O and the O, and it will be in between two carbons. So there will be a carbon on the right there and another carbon on the left. So here it says the structure of the functional group. So number one there, you need to know what the structures of all the homologous series. Then, very important, you need to know what the name of the functional group for all the homologous series according to the examination guidelines there. Then IUPAC naming. So IUPAC naming means what? International Union of Pure and what? And Applied what? Chemistry. And then for the alkanes, you need to know the name ending there is ane. So for example, if we had a pentane, then the name ending as highlighted there would be an ane. Alkene, the name ending there is what? Is ene. Alkyne, triple bonds, the name ending there is what? Is ine. Then the haloalkanes, as we can see here, they have the same name ending as what is our alkanes. Then aldehydes, if it was an alkane, then what are we doing in terms of aldehydes? We are just removing the E, we are replacing it with what? With the al. And then again, ketones. So ketones, if it was an alkane again, what are you doing? You are going to remove the E, and then instead of you having a pentane, then you'll have what? A pentanone. So you are removing the E, you are replacing it with what? With the on or with the one. Then alcohols, so we just spoke about primary, secondary, and what? And tertiary alcohols. The name ending, it ends with the all or with the all there. And then again, if it was an alkane, you will have a pentane, but because it's an alcohol, then what are you going to have? A pentanol. Carboxylic acids, the name ending is what? Is oic acid. And if it was an alkane, you just remove the E, you replace it with the what? With the oic acid. Okay, so again, the sum of the homologous series, they do give you a clue as to what the name ending will be. For example, alkane, we can see that you'll have an ane. Alkenes, it's a in. Alkynes is a ine. And then ketones, we have a one there. Alcohols and the acids. And then the last one there is what? Is esters, and your name ending will be what? Will be O8. So make sure that you know all the name endings so that you are able to do your IUPAC naming properly. Then again, it says the name of each organic molecule has what? It has 3 parts. So we have a prefix, and then it says it is the type and the position of the what? Of the substituents. So positions are very important. Then it says here you need to identify the alkyl what? Substituents. For example, methyl and ethyl in a chain to a maximum of 2 alkyl substituents on the what? On the parent chain. So for example there, your methyl, so for example if this was your chain, your methyl would be this one. So methyl means that you have what? It means that you only have one carbon in that chain. So if it was an ethyl, then an ethyl would mean that you would be having how many? You would be having a total of what? Of 2 carbons. So you need to identify what? You need to identify a methyl, that is what? A total of what? 1 carbon. And then 1 carbon, which can also be represented by what? By CH3, because it's 1 carbon and 3 hydrogens. And again, you need to identify an ethyl, which can be represented also by CH2 and then what? CH3. So CH2 from where? This carbon, the 2 hydrogens, which is the CH2 part, and this carbon, and how many? And 3 hydrogens, which is the CH3 part. Then it says, when writing the IUPAC names, substituents appear as what? They appear as prefixes. So this methyls and ethyls and bromo and chloro, they are going to be appearing as what? As prefixes. And what is important is that they need to be written what? Alphabetically. So if it is going to be in alphabetical order, we have a bromo, a chloro, ethyl, and methyl. So which one will come first if we are going to consider alphabetical order? The B is before the C, and the E is after the C, the M is after the E. So whenever you write or whenever you do your IUPAC naming, you need to consider what? Alphabetical order. And then very important, it says you ignore the prefixes what? A di and what? And tri. So it means that, for example, if you have, what? A dimethyl, and you also have a bromo, and you need to write these two in terms of alphabetical order. The rules are saying that you need to ignore what? You need to ignore this di. So meaning that what is going to take priority in terms of the two then, in terms of alphabetical order, the B comes before the what? Comes before the M. So therefore it means that your bromo will be written first and then followed by what? Followed by the dimethyl. So again, maybe another example. If you have what? If you have, let's say you have a chloro, and then you have what? You have a dibromo. Di means what? It means that you have 2 bromines. And then again here, di means that you have what? You have 2 methyls. So the rules are saying what? The rules are saying that you are going to be ignoring this di. What is important? You are going to consider alphabetical order only in terms of the substituents, which is what? Which is a bromo and what? And a chloro. So between a bromo and a chloro in alphabetical order, which one is going to come first? It's going to be the bromo, followed by what? Followed by the chloro. Why? Because remember, the rule said what? The rule said that we need to ignore the what? The di. So you are going to ignore this di as well as the tri. So tri means what? Means that you have 3. So it can be 3 of the methyls, 3 of the bromos, 3 of the chloros, or 3 of the what? Of the ethyls. So tri basically means 3, and di means what? Means 2. So parent, it says the number of carbon atoms in the what? In the longest chain. So the number of carbon atoms, so you must know that if you have 1 carbon, then it's going to be a meth. If you have 2 carbons, an eth. 3 will be prop, 4 will be but, 5 pent, and then 6 will be what? Will be hex. Then the type of functional group, so the suffix will be the type of what? Of the functional group or the homologous series. So that is what we previously spoke about. The suffix ending to say alkane will end with the what? With the ane. Alkene will end with the what? With the in. Okay. So let us have a look at this activity here. It says organic molecules from different homologous series are represented in table 1 below. Okay. 2.1 that says you need to define what? The term hydrocarbon. For how many marks? For 2 marks. But before you even go to the definition, you will see that it says you define what? Hydro. So already you can see that the hydro has to do with what? It has to do with hydrogens. And then the carbon, obviously then it means that it's what? It's the carbon there itself. So let us have a look there. It says hydrocarbon is an organic what? Is an organic compound containing only what? Containing only carbon atoms and what? And hydrogen atoms. So again, from the word itself, it is an organic compound that is containing what? Only carbon atoms and what? And hydrogen atoms. And you can also get the definition from what? From the word itself. So remember, with the definitions, you need to define according to what? According to the examination guidelines. Then the next one here says, draw the structural formula of the compounds represented by the following what? By the following letters. Okay. So before you draw the structure, then you need to be able to identify what? The homologous series. Okay, so we see that on this one, on letter C, what is it that we have? We have a chlorine. From the condensed structure, are we able to see anything else? The only thing that is giving us guidance is what? Is the chlorine, which means that we must be having what? A haloalkane. The next thing is that you count what? You will count again the number of what? The number of carbons. So we see that we have how many? 1, 2, 3, 4. So we have 4 carbons. So you know that whatever structure that you are going to draw will also consist of what? Will also consist of 4 carbons. Okay. So let us have a look at the structure there. So the first part, it has what? It has 1 carbon. So you draw your first carbon, and then the next thing is what? Is the 3 hydrogens. So it's 1 carbon, and then hydrogen number 1, number 2, and what? And hydrogen number 3 there. The next thing is what? Your second carbon, and how many hydrogens? And 2 hydrogens. So you draw your 2 hydrogens there. And the third one, there is your carbon. And how many hydrogens does it have? It has 2 hydrogens. Then the last one has what? It has 1 carbon, and it also has what? It also has your 2 hydrogens, which is representing the H2 part. But again, you will see that you also have what? You also have the chlorine. So you also need to represent the chlorine part. Okay. Then again, just to make sure, what you can do is you can then count the number of carbons that you have there, and the number of carbons and the number of hydrogens that you have, they must also match what? The number of carbons and the number of hydrogens that you have according to your structure. And you will also check the number of what? The number of chlorines that you have there on your condensed structure, as opposed to what? As opposed to your structural formula. Then the next one says you need to draw the structural formula of what? The structural formula of compound E. So again, we need to identify what? We need to identify the homologous series. What is the homologous series of this compound? We see that we have an ol. So if we have an ol, it means that this must be what? This must be what? An alcohol. And that alcohol, the next step is what? How many carbons will this alcohol have? So what is giving us a clue? The but is giving us a clue. So the but, we know that we have a total of how many carbons? We have a total of 4 carbons. Then next, we see that we have a 1 ol. That means that on position number one, we must be having what? We must be having the alcohol, or a representation of the alcohol. And how are we going to indicate the alcohol? We are going to indicate the alcohol using what? Using the OH. Okay, so looking at the structure, we said that we are going to have a total of what? Of 4 carbons. So it's 1, 2, 3, 4 carbons. And then we said, what is the homologous series? We said it's an alcohol. Why did we say it's an alcohol? Because we said that we have the word "ol", which is representing an alcohol. And we also said that on position number 1. So position number 1 would be this one here, counting from where? So 1, 2, 3, 4. Counting from the right hand side, that would be position number 1. And that is where we have the what? That is where we are going to have the OH. And then again, if you decide to draw it in this way, this is also what? Correct. So if you decide that instead of you having the OH group towards or on the right hand side, if you decide that you want to have the OH group on the left hand side, that is also correct. So again, this is carbon number 1, number 2, number 3, and number 4. That is when you are counting from where? That is when you are counting from the left and then going where? Going to the right. But if you look at this one, the OH group is still on carbon number 1 when you are counting from the right and then going where? Going to the left. So this structure and this structure, they are all correct. It's just that the OH on this one is on position, is on the left hand side, and then the OH on this one is where? Is on the right hand side. And then again with the alcohols, you must also be very careful when it comes to writing what? When it comes to writing the OH. As you can see, if this is your carbon, what are you going to draw first? You are going to draw you are going to write the oxygen and then the hydrogen. You are not going to draw the what? You are not going to draw or write the hydrogen and then the oxygen. So this structure would be wrong. You need to have what? You need to have the oxygen and then followed by what? Followed by the hydrogen. Okay, learners, so for this one, I'm going to give you 4 minutes to do this one. 4 minutes, and then we can be able to do it together. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, so let us continue. 2.3 says you must write down the IUPAC name of what? Of compound B. So remember, before you write down the name, you need to identify what? You need to identify the homologous series. So let us have a look. We can see that we have what? We have a C double bond O and the O. So that means that we have what? We have an ester. So remember, an ester has what? It has two parts, right? So it has the alcohol part and the what? And the carboxylic acid part, right? So let us check now which one will represent the alcohol part. The alcohol part would be this one here, which is connected to what? To the oxygen. And then the carboxylic acid part would be this one, which is connected to what? To the C double bond O. Right, so from there, remember, how are you going to name an ester? You start with the alcohol part first. So this would be your part A, and then followed by what? Followed by B, which is representing your what? Which is representing your carboxylic acid part, right? So the alcohol part, how many carbons does it have? We can see that it has what? It has one carbon. So if this one was if it was an alkane, then the alcohol part would be called what? A methane. But because now we are naming what? We are naming an ester. What are we going to do? It means that we now remove the A and then we replace it with the what? With the YL, so that it becomes what? A methyl. Then B, it's the carboxylic acid part. So how many carbons does it have? We can see that it has what? It has two carbons. So actually, because it has two carbons, if it was an alkane, so we would therefore call it what? If it was an alkane, we would call it what? An ethane. So, but then because it's an ester, therefore we are going to call it what? Ethanoate. So we are going to remove the E. So therefore, the name would be what? The name would be methyl. But for the other part, which consists of two carbons, we are therefore going to call it what? Ethanoate. So we remove this one here and then it be called what? An ethanoate. So what did we do? We removed the E of what? Of the alkane, and then we are replacing the E with the what? With the O8. Okay. 2.4.1, write down the homologous series to which the following compounds belong. So again, for you to be able to do this one, it is best if you draw the what? If you draw the structure. So the structure would therefore be what? CH3. Why? Because we have one carbon there and three hydrogens, and then CH2. So it's one carbon and what? And two hydrogens, and then CH2 again. It's one carbon and what? And the two hydrogens, and then we also have what? The last part is what? Is your CH what? Your CH3. So if you look at this compound A, you will see that you only have what? You only have single bonds. So therefore, this would be represented by what? By an alkane. And then letter B, again, we need to write down the what? The homologous series. So remember, we said because we have the C double bond O and the O there, therefore it will mean that it represents what? It is representing an ester. So because of what? The C double bond O there in between, C double bond O and the O, we said this would be representing what? An ester. 2.5, compounds B and D. they are what? They are structural isomers. Okay. 2.5.1, we need to define the term what? A structural isomer for 2 marks. And it says the structural isomers are organic molecules with the same what? With the same molecular formula, remember that? But with different structural formula. So, remember, again, for you to prove it, same molecular formula, we can see from observation of the structures that we have what? That we have different structural formulas or formulae. And then how can we see that? This one is representing an ester, but this one, it has a C double bond O and the OH, which means that it is representing what? It is representing a carboxylic acid. Then it says, so we said same molecular formula, so we can check that. How many carbons does this one have? It's 1, 2, 3 carbons, so we write C3. How many hydrogens? 1, 2, 3, 4, 5, 6 hydrogens, so we write H what? H6. And then how many oxygens this one has? It has 1, 2 oxygens. So that would be the molecular formula of the ester. What about the carboxylic acid? How many carbons does it have? It has 1, 2, 3 carbons, so we write C3. How many hydrogens? 1, 2, 3, 4, 5, 6 hydrogens, so we write H3, C3, H6, and then how many oxygens? We can see how many oxygens? We can see 2 oxygens. So according to the definition, it says same molecular formula. Look at the molecular formula of the ester, C3H6O2. Look at the molecular formula of the carboxylic acid, C3H6O2. So according to definition, same molecular what? Molecular formula. Look at the structures. This one is an ester. It has C double bond O and the O in between 2 carbons. Look at this one. This one is a carboxylic acid. It has a C double bond O, OH, and it's not in between what? It's not in between the carbons. So the structures are different, but the molecular formulas are what? The molecular formulas are the same. So that is an isomer. Then 2.5.2, what type of structural isomer are compounds B and D? Okay, so remember, in terms of isomers, we have what? We have chain, where we are changing the length. Then you need to check to say, okay, did I change the length of this one? You did not change the length. Did I change the position? No, you did not change the position. But what has changed? You changed the functional group. Because here again, we said we have a what? A C double bond O and an O. And then here you have what? A carboxylic acid. So it means that you could have used the CAKE to check what type of isomer you have. Remember I said, if you are given what? A carboxylic acid, then you are going to write what? An ester. And then if you are given a ketone, then you are going to write what? An aldehyde. Or if you are given an aldehyde, then you are going to write what? A ketone. Okay? So when it comes to this one, you were given a carboxylic acid, so therefore, or you were given both the carboxylic acid and the what? And the ester, and then you just had to identify. So where do you use the CAKE? You only use this whenever you have what type of isomer? Whenever you have a functional isomer. So the question says, what type of structural isomer is B and D? And our answer would therefore be what? A functional isomer. Why? Because we had what? A carboxylic acid and what? And an ester. Okay, then the next one, organic molecules can be classified into different homologous series that are identified by their functional groups. 2.1, it says that we need to define the term what? Functional what? define the term functional group. Then again, for definitions, you need to define according to what? To the examination guidelines. So it says an atom or a group of atoms or bond that determine the what? The chemistry of a molecule. So make sure that you get your definitions correct there. 2.2, consider the organic molecules in the table below and answer the questions that follow. Write down the name of the homologous series of compounds represented by what? Represented by A. Again, remember this one, it ends with the what? It ends with the "in." So remember, we have alkane, alkene, and then what? And then alkyl. So alkene, this is your double bond. So alkene in double bond, and that would be what? That would be a alkene. 2.2.2, the name of the homologous series represented by B. What are you going to look at? Now, if you are given a structure, then you look at the C double bond O and the H there at the end. So C double bond O and the H, and that would be represented by what? By the aldehyde. Right? Letter C, you see it's different from letter B. Letter B, we had C double bond O and the H. But then now for letter C, what do we have? C double bond O and OH. So that would mean that it's a what? It's a carboxylic acid. So you see, just to identify how many marks are you getting there, you are going to get 3 marks. So again, if you are maybe asked to identify this one on, then you would know that it's a what? It's a ketone. Then the next one, write down the IUPAC name of the organic compounds represented by what? Represented by B. Okay, so for the IUPAC name, remember, first thing always identify the homologous series. So what is the homologous series? We said it's a aldehyde. Why? C double bond O and H there at the end. So from there, after identifying, then we can talk about what? The name ending. Aldehydes, they end with the what? They end with the al, right? So what's the next step? You need to count the number of carbons. How many carbons? 1, 2, 3, 4, 5, and what? And 6 carbons. But remember, right now we do not have any branches. So what is going to take priority in terms of numbering? It is going to be the functional group. So meaning you will have to count from the right. So 1, 2, 3, 4, 5, 6. That would be the correct what? The correct numbering. So that the C double bond OH is on carbon number what? Is on carbon number 1. Right. So because it's 6 carbons, it means that the name will be what? If it was an alkane, then the name would be what? Would be hexane. But because it's an aldehyde, you are going to remove the E, and then what do you replace it with? You replace it with the al, so that it becomes hexanal. Then letter C, IUPAC name again. We have identified homologous series is what? Carboxylic acid. Why? C double bond O and the OH. Okay, so from there we talk about what? The name ending. Name ending for carboxylic acid is what? Oic what? Acid. Next, how many carbons? So it's 1, 2, 3. What is going to take priority in terms of numbering? It's going to be the functional group, which is what? C double bond O and the H. So it takes priority, meaning when you start counting, you start counting from the functional group, or from the C double bond O. Right. So from there, if it was an alkane, then the name would be called what? the name would be called a propane, meaning that we have what? We have 3 carbons, but because it is a carboxylic acid, what are you going to do? You remove the E and then you replace it with the OIC so that it becomes what? Propanoic acid. Okay, because remember we said the name ending is what? Is oic acid. Then the next one, 2.4, draw the structural formula of the organic compounds represented by what? Represented by A. Okay, so A, we said the homologous series is what? Is alkene. Then next, because you must draw, then you look at this part, bute. Bute means you have how many carbons in total? You have 4 carbons in total. So ene is an alkene. It means what? It means you will have what? Double bonds. Where are you going to have those double bonds? There is a position on position number 2, right? So what are you going to do? You are going to draw your 4 carbons. There's your 4 carbons. 1, 2, 3, 4 carbons. And then from there, so if I am to redraw, so you will draw your 4 carbons, then from there on carbon number 2. So if this is carbon number 1, number 2, on carbon number 2, what are you going to draw? You are going to draw what? A double bond. So from there, you need to put what? You need to put your hydrogens. So it means that you will put hydrogens there, hydrogens on this one, hydrogens on this one, hydrogens on this one, and this one. Why are you not going to put hydrogens on carbon number 2 and carbon number 3? Because remember, carbon must have a maximum of how many bonds? Of 4 bonds. So you will see that already this is bond 1, bond 2, bond 3, and bond 4. So meaning that if you are going to put a hydrogen on this one, then it means that your carbon will have a total of what? 5 bonds, which is what? Which is incorrect. Again, if you check this one, it has 1, 2, 3, 4 bonds. So again, if you are going to put a hydrogen there, it will mean that your carbon will have a total of how many bonds? A total of 5 bonds, and of which that is what? That is incorrect, because carbon can only have a total of what? Of 4 bonds. So that is why you cannot introduce what? You cannot introduce, or you cannot write what? The 2 hydrogens on this position. So you cannot write the hydrogen here, and you cannot write the hydrogen here on those positions. And does it matter whether the hydrogen is on top here or at the bottom here? So does it matter whether it's here or here, or this one? Does it matter if it's at the bottom or at the top? It does not matter. But as long as on carbon number 2 and on carbon number 3, you have what? You only have a 1 hydrogen. Then the next one, it says you must draw the structural formula of what? Of compound D. What's the first thing? What is the homologous series? Where are you going to see that? You have an ON. So because you have an ON, it means that this must be what? This must be a ketone. What's the next step? Look on the left hand side, you have a pentane. If you have a pentane, it means that you have how many carbons in total? It means that you have 5 carbons in total. So because this is a ketone, because of the ON, where is this ketone going to be? It's going to be on position number 2. So how do you see that you have a ketone? A ketone would be represented by C double bond O, which is between what? Which is between two carbon atoms, right? So where do you start then? You can start by writing your what? Your 5 carbons. So you will see that you have a total of what? 1, 2, 3, 4 what? And then 5 carbons. Again, so you will have your carbons and what? Your hydrogens. Carbons, hydrogens, carbon and hydrogen, carbon and what? And hydrogen. And then again, what is important there? What is important is that on position number 2, what do you have? you will have a representation of what? Of the ketone. So that representation is what? Is C double bond what? C double bond O will be on carbon number what? Will be on carbon number 2. So where did you start? You said homologous series, the ketone, and therefore you showed the functional group there, and then you said pentane, how many carbons? You said 5 carbons. And then position number 2, you showed your C double bond what? Your C double bond O. Okay. Then 2.5, it says draw the structural formula of the isomer of organic compounds represented by what? Represented by A. So remember the isomers, we have 3. We have chain, where you will be changing the chain, and then we have a positional isomer, then we have what? A functional isomer. So with the positional isomer, it will be changing the position. So already when you see this but2 in, it means that you must be changing the what? You must be changing a position. Okay, so but2 in, you will need a structure of the but2 in, and then from the structure we can see that a homologous series is what? Alkene, but. How many carbons in total? 4 carbons in total, right? From there, the but is the double bond, which is on position number what? Number 2. So this can be carbon 1, 2, 3, and carbon 4. Or from the right, it can still be 1, 2, 3, and 4. So you can see that whether we are counting from the left or from the right, we are still going to maintain the same position of the double bond, right? So from there, you'll have to draw your what? Your hydrogens. So you will see that you have a problem on carbon number 2. You cannot draw what? Another hydrogen. Why? Because carbon already has 4 bonds. Again, on carbon number 3, you will see that you cannot draw what? You cannot draw the hydrogen. Why? Again, carbon already has 4 bonds. So if you introduce another hydrogen, it means that carbon will be having a total of what? Of 5 bonds, which is incorrect. So you move on to the next one, and that will be your structure of what? Of but2 in. So remember, the question said draw the structural formula of the isomer. The question did not say you must draw the structural formula of compound A. It said that you need to draw the what? The structural formula of the isomer for the following, for A. So meaning before you draw the isomer, you need to know the what? The original structure, so that you are able to do what? To move the positions, right? So we can see that on this one, carbon number 2, that is where we have what? We have a double bond. So if you are going to draw the isomer, then what can you do? This double bond is already on carbon number 2. So it's either then you are going to move it to carbon number 1. So this is carbon number 2, number 3, and number 4. So now when you draw your structure, it's either you move it between what? Between carbon number 1 and carbon number 2. Or you can move it between what? Between carbon number 3 and carbon number 4. That would be exactly the same structure, because where was it? Initially, it was in between carbon number 2 and carbon number 3. So it means that by 2.5.1, what have we done? We have changed the what? The position of the double bond. On the original, the position of the double bond was on carbon number what? On carbon number 2. On the new one, the position of the double bond is now on carbon number what? On carbon number 1, right? So again, another option, you can change the chain. So originally, the longest chain had how many carbons in total? The longest chain had 3 carbons in total. Right now, the longest chain has how many carbons? You can draw a structure that has how many carbons? That has 3 carbons in total, and what? And a branch. So I'm just repeating. Originally, the longest had 1, 2, 3, 4 carbons on the longest chain. On this one, now the longest chain has 1, 2, and what? And 3 in total. So you can have that option whereby you change the what? You change the chain, so that would be called what? A chain isomer. This one, what did we do? We changed the position of the double bond, hence that will be called what? A positional isomer. Then let us see, it says that we need to draw the structural formula of the isomer. So again, you need to keep in mind we have chain, we have positional, and then we have what? Functional. But with this one, immediately you can see that you are given what? You are given a carboxylic acid. Then it means that you can use the word what? CaKe. So if you are given, remember we said if you are given a carboxylic acid, then you need to draw what? An ester. Or if you are given an ester, then you are going to draw a carboxylic acid. Or if you are given an aldehyde, then you need to draw a ketone. If you are given a ketone, you will need to draw what? An aldehyde. So in this case, what are we given? We are given a carboxylic acid. So it means that we need to draw what? We need to draw an ester. So with the ester, remember we said it's a combination of what? Of alcohol. So meaning we'll have your C double bond O, and the O and then H there, which represents what? This part will represent the carboxylic acid part, and then this part will represent your what? Your alcohol part. So the one that has the O, it represents the alcohol part, and then the one that has the C double bond O will be representing your what? Will be representing your carboxylic acid part. Another option, as you can see on this structure, you have the carboxylic acid part only having 1 carbon, and then on this structure, what do you have? The carboxylic acid part has a total of what? Of 2 carbons, and then the alcohol part on this side has a total of what? Of 1 carbon, and on this side, the alcohol part has a total of what? Of 2 carbons. So again, to verify your structures, what is it that you are going to do? Remember, according to definition, isomers have the same molecular formula. So meaning that you need to count the number of carbons. So how many carbons do you have there? You have 3 carbons. And then how many hydrogens do you have there? We can see that you have 6. So it's 1, 2, 3, 4, 5, 6. And then how many oxygens? You have 2 oxygens. And then again, to verify, you can count the number of carbons that you have there. So how many carbons do you have there in total? It's 1, 2, 3 carbons. And then how many hydrogens? 1, 2, 3, 4, 5, 6 hydrogens. How many oxygens? 1, 2 oxygens. So when you are done drawing your structures, you then need to write your what? Your molecular formula, so that you can verify that you have the exact number of carbons, the exact number of hydrogens, and the exact number of what? Of oxygens. So as we can see, how many do we have there? 3 carbons, 6 hydrogens, and 2 oxygens. And again, on the esters, how many? 3 carbons, 6 hydrogens, and what? And 2 oxygens. Okay, the next one, identify the type of isomer in 2.6.1. We spoke about that one. We said it is going to be either a positional isomer or what? Or a chain isomer. And then the one for 2.6.2, we also spoke about that one. We said for that one, we used what? We used the CAKE. We were given a carboxylic acid, so we had to draw esters. So therefore, that type of isomer would be represented by what? By a functional isomer. Then consider compound A. Is compound A saturated or what? Or unsaturated? Okay. So how do you identify that one? Remember, saturated would mean that you only have what? Single bonds. But if it is unsaturated, then it means that you have what? You have more than 2 bonds there. So how do we now know? We can see that we have an in. If we have an in, what is the homologous series? It means that the homologous series is what? Is alkene. Okay. So if it is alkene there, it will mean that it is what? It is unsaturated. So 2.7.2 explain the answer to question 2.7.1. Then it says it contains what? Carbon-carbon double or what? Or multiple bonds. So even if you are to draw the structure, you will see that on carbon number 2, because of this in, you have what? You have a double bond. Okay. Okay, learners, I'm going to ask that we take a 2 minutes break. A 2 minutes break, and then I'm going to continue with this activity here. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number 063-508-1301. Okay, let us continue. It says the letters A to F in the table below represent 6 organic compounds from different functional groups. Okay. 2.1 says we need to define the term what? Define the term functional group. And then it says an atom or a group of atoms that determines the physical and the chemical properties of a group of organic what? Compounds. So remember with definitions, definitions will be 2 marks or nothing, and you need to define according to what? Define according to the examination guidelines, right? 2.2 says here, write down the name of the functional group to which the following compounds belong. So remember, learners, you need to do what? You need to read carefully. It did not say you must write down the homologous series. It said you must write down the name of the what? Remember the table that we did? The name of the functional group. Okay, so again you need to have a look at what? Have a look at the structures. So what is it that we see there on compound A? We see a C double bond O, and it's in between two carbons there. So it means that this must be what? This must be a ketone. So because it's a ketone, therefore the name will be what? The name will be carbonyl, right? The next one is what? We can see that for the homologous series, remember, you always need to identify the homologous series, right? So for the homologous series, compound C would be what? Would be an alcohol. So because it's an alcohol, what is the name of the functional group of alcohols? That would be what? A hydroxyl. Then 2.3, write down the name of the what? Now they're asking you for the name of the homologous series, right? So because we said it's a C double bond O and it's in between two carbons, we said the name of the homologous series would therefore be what? Would therefore be a ketone. Next one, 2.3.2. You need to write down the IUPAC name of compound what? Of compound F, right? So before you write down the name of compound F, you need to identify what? You need to identify the homologous series. So what is it that we can see there? We can see that we have a triple bond. So because we have a triple bond, so it means that this must be what? This must be an alkyl, right? So again, what is the next step? The next step is that you need to count the number of carbons. So we have 1, 2, 3, 4. So if we have a total of what? Of 4 carbons, if this was an alkane, then the name would be called what? The name would be butane. Okay, so because this is now an alkyne, what is important here? You need to indicate the position of what? The position of the triple bond. So what are you going to do with that name? So I said if it was an alkane, right, the name would be called what? Butane. But because it's an alkyne, then the name is butyl. So you just replace the N with what? With the Y and E, and then you need to indicate the what? You need to indicate the position. So let us have a look there. The triple bond is on carbon number what? Is on carbon number 2. So therefore you need to separate the name and write what? But-2-E. So with the 2 there, what are you indicating? You are indicating the position of what? Of the triple bond, and the ion would be the name ending of what? Of the alkynes. 2.3.3, the structural formula of what? Of compound E. Again, you need to identify the what? The homologous series. Where does it belong? It ends with an al. So therefore, what is the homologous series? This must be what? An aldehyde. So an aldehyde, this is the structure of the aldehyde. What is the next step? The next step is this aldehyde. How many carbons does it have? The full name is what? Is butanol. This means that this aldehyde must be having a total of what? Of 4 carbons, right? Then there's more. On carbon number 2 of this aldehyde, we have what? We have a 2-1 methyl. So meaning meaning the first thing is that we have a total of 4 carbons. But from the very same carbons, on carbon number 2, what do we have? We have a methyl group. Then we must remember a methyl group. What is a methyl group? It is the CH3. It is CH what? CH3. So looking at the structure will have what? A total of 4 carbons. So it's 1, 2, 3, what? 4 carbons. So remember with aldehydes, what is going to take priority in terms of numbering? what is going to take priority will be the functional group, which is the what? Which is the C double bond O and the what? And the OH. So remember, you're also allowed to draw it in this way, C double bond O, and with the H there on the side. So that is also correct. So again, we said total of 4 carbons. So counting from the functional group, and then on position number 2, we said we have what? On position number 2, we said we have a methyl group. So there's carbon number 2, here it is. And then on position number 2, what are you going to have? You are going to have a methyl group, so as well as your hydrogens and your other hydrogens on the other carbons. So remember, when you draw all of this, you need to make sure that carbon has a total of how many bonds? Carbon must have a total of 4 bonds, right? 2.3.4, it says letters representing the what? Letters representing the structural isomers. Letters representing the structural isomers, okay? So it's going to be letter what? Letter B and letter F. But remember, for you to be able to identify this structural isomers, then it would mean that you would need to do what? You would need to draw the structures. So but 1-ene, it's a what? The homologous series, it ends with the I. So the homologous series would be what? Will be alkyl. And then how many carbons are you going to have? Because of this but, it means that you have a total of what? Of 4 carbons. And then on position number 1, you have the ine, which is what? Which is your triple bonds. So that's a carbon number 1, number 2, number 3, and number 4. So on carbon number 1, you have a total of you have a triple bond. So therefore, you now need to draw your what? Your hydrogens. So how many hydrogens can this carbon number 1 accommodate? It can only accommodate what? It can only accommodate 1 hydrogen. Why? Because carbon can only have a total of what? Of 4 bonds. So meaning that you cannot draw a hydrogen here, and you can also not draw a hydrogen there, because it will now mean that your carbon has more than what? More than 4 bonds. So again, carbon number 2, how many hydrogens can it accommodate? It cannot accommodate any hydrogens at all. Why? Because it already has 4 bonds. It has 1, it has 2, it has 3, and then it has 4 bonds already. So you cannot draw another hydrogen here and draw another hydrogen there. Then the next one, how many bonds? It has 1, 2 bonds. So it means that we can still accommodate another hydrogen or 2 more hydrogens, so that we have a total of what? Of 4 bonds. And then the last one, how many bonds does it have? It only has 1. So it means that we can be able to draw what? 3 more bonds. So this would be the structure of this B. This would be the structure of what? This would be the structure of B. Now it says letter representing what? Structural isomers. So what have we done? For but 1-ene, the triple bond, where was it? The triple bond was on position number 1. But for compound F, where is the triple bond? The triple bond is on position number 2. So remember, for letter F, it does not matter whether you are going to be counting from the left to the right or from the right to the left, because the triple bond is not going to change in terms of numbering. So for example, if it's from the right, it would be 1, 2, 3, and what? And 4. So still, the triple bond is still going to be on position number what? On position number 2. So if you are to be asked what kind of an isomer or what kind of isomers do we have here, it means that because you change the position on letter F, you change the position of the triple bond from position number 2 to carbon number what? To carbon number to position number 1. So therefore it would mean that we have what? A positional what? Isomer. Okay. Then 2.3.5, it says letter representing a compound, which is what? Which is an alcohol. Okay, so for an alcohol, what is it that you are looking for? You are going to be looking for the OH group there. So because of the OH group there, so it would mean that we have letter what? Letter C. Then 2.3.6, it says structural formula of the isomer of what? Of compound D. So what are you going to look for? That structural formula, the name ending there is A, so meaning that we have what? We have an alkane, and then we have a bute, meaning that we have a total of what? Of 4 carbons. So you'll have 4 carbons. But the question was saying that you need to represent what? You need to represent the isomer. So it would mean that first you will need to write what? You will need to draw the structure. So this would be representing what? This would be representing the structure that has a total of what? Of 4 carbons. And from the 4 carbons, what have you done? You have just changed the what? The chain, because the original structure was consisting of 4 carbons, and the isomer now has a total of 3 carbons in terms of the longest chain and a methyl group. Then 2.3.7, it says the letter representing a saturated compound. So remember we said a saturated compound would be a compound that consists of what? Of single bonds. So that compound would be letter what? Letter D. Okay, learners, so for today, we have ran out of time, and that would be the end of our lesson. So maybe you can take a screenshot and I'll give you this as your homework. So you can also take a screenshot of this one here. And this part here. And this one here. So with all that, learners, thank you very much. And again, I will be leaving you again with the words of Nelson Mandela. And again, I will see you next time as we continue with organic chemistry. As we continue with organic chemistry, that is going to be again question 2, and also going forward we'll also be continuing with organic reactions. Okay, thank you, learners, and I'll see you next time. Goodbye for now.